And it is about rebuilding. It's really hard to plug holes. We tend to talk about Swiss cheese. You use the metaphor, you know, a kid's understanding is like Swiss cheese, and you got to find out where the holes are, and then you plug the holes. That hardly ever works, because the things we plug the hole with aren't the same cheese. And so it doesn't belong. So it's like, you didn't get this, and we were talking to this woman who's dealing with this issue in high school, where kids are coming in with this very scattered set of understandings. And so it isn't like I can plug all those holes, because all of a sudden it isn't a hole anymore. It's not coherent. The way it works is if you have a coherent progression. And so you've really got to find the place where I'm going to rebuild, and I've got to make sure that I connect. And I start with the concrete, what's something that is familiar with kids, and then I build on that. This is, this has been proven again and again. This is this model they use in Singapore and in high-performing countries. You see it in the RTI report that just came out yesterday or day before from the Doing What Works Clearinghouse. How do we teach this stuff? Concrete, using visual models to help generalize that, and focus on one model first, and I would say one model that is common across the number forms. We like number lines. Research talks about we have a mental number line where we have actually some kind of linear spatial representation we use for quantity. And it changes as we learn. The one we're born with is logarithmic. When they test infants and young kids, and they go to places in the Amazon and in Southeast Asia where they test tribes who've had no education, and they do things with them about how they count and represent quantity, it goes 1, 2, 3, 100, 200, 3, a million. It is a logarithmic representation. It's not equally spaced. Once they get formal education, that logarithmic linear representation, which almost always goes from left to right, you watch gestures, and they do all these studies, it's very universal, shifts from a logarithmic to a linear one with equally spaced pieces. And a million is way out there. And the difference between 0 and 10 is much closer. And that kind of representation changes with time. You want to have that. So we like to build over what's natural, that linear representation, and moving to a number line and have all our number forms work there. We do that with whole numbers, we do that with fractions, we do that with decimals, and then you vary. You build solid with one and then vary. If you give them a bunch, you have this cognitive load issue. Which one do I use when? What's the idea? Get them solid and then vary. Because you do want to have fluidity. You want to be able to represent it other places. It isn't just solid with one. You do want to be able to vary. But it's varying off of a solid base. And then you move to the symbolic. So this transition, rebuild with what the kids know. You have to have things connected. You have to find out, what did you learn before? Where can I pick up on that you already know so I'm not confusing you? And it's hard in high school. The later you do this, the harder it is. Because you've got kids who've come from different schools, who've had different teachers, different informal experiences. It's a real mix. And that's also a place where technology can help, because it can then help individualize that experience for kids. So that's a progression that we like. Foundational concepts, the unit whole. What we found is you start the concept of a unit. What is a unit? And that's the foundation. And that's the same thing you do with whole numbers as well. The unit is 1. How many of those units are there? And then I can break that unit up, and now I have a unit fraction. How much is one part of that unit? And I have to have the same unit in order to be able to combine them and do things with them. And that's the same common denominator issue. The common denominator of whole numbers is 1. 2 over 1, 3 over 1, 4 over 1. 1 over 1 is 1. It's the same concept. If you take that same concept and use it, you already know how to do this. We're doing the same things you do with whole numbers. With whole numbers, we're adding things that are the same unit. Same thing now with fractions. You already do this. We just have to know what's the unit. How many? What is it? And it's all based on the unit whole. Same representation. And then you build on in small increments. The thing we're developing looks like a lot, but because each one is small. There's never that much new to learn. And you're building on what's already there. Always connect what you knew to what exists, and don't give a lot at once. Some kids can handle a lot. But the kids who are struggling can't. That's why they're struggling. And when you try and fill in everything at once, oh, wow, you missed a lot. Here's all the stuff you missed. It would go into like demand is like boom, and my resources are like really light, and I'm in cognitive shutdown. I can't possibly do that.